will keep numeric as numeric, but categorical has two variations. They have some importance. One is called nominal, the other is called ordinal. Nominal, employee ID or the jersey numbers of the cricketers, or gender, male, female. There is nothing else. You can't talk about anything else. There is no mathematical thing. There is no hierarchy. Male, female equal. Religion, any number of religions. There is no hierarchy. They are just categories. 4, 5, 10, 15 different categories. Ethnicity, pin codes, Aadhaar numbers, city, which place were you born in. They are just given a different category. So these are called nominal, where there is no difference between anything. They are all the same. It's just different categories. Ordinal, on the other hand, there is an order. That's why it is ordinal. Order is there. For example, movie ratings. You see some movies rated 1 star, 2 star, 4 star, 5 star. How can I do calculation or not? If there is an order, like mutual fund risk ratings or Fortune 500, but not as good as good. Very good. Whatever. So that gives you some meaning. So it is okay to do those kinds of mathematical calculations in ordinal data. But even otherwise, whether you are able to do calculation or not, if there is an order like mutual fund risk ratings or Fortune 500 companies, you know, in Fortune 500 company, which is number 1, means it has the highest revenue or whatever, market cap, highest market cap. The second one, I cannot tell how much difference is there between the two companies, but it is less than the first one. The third one is less than second. Doesn't mean that the difference between the third and the second is the same as between the second and the first. There is no other meaning to that, but you know there is an order. So those are ordinal level data, and sometimes it is reasonable enough to do some kinds of calculations in ordinal level data. Nominal level data, nothing. We just have. And we will see in linear regression when we see those kinds of things. How do I deal with that data and put that in an equation? We'll cover that. But at this time, categorical data, 2 types. Nominal, ordinal. Ordinal has some order, nominal has no order. Numerical data, heights of people, weights of people, you can see relationship between those things, temperature, time, volume, number of anything, number of employees, whatever, these are all numerical data. Then very, very importantly, because a lot of the probabilities and everything depend on these things, this data can be discrete or continuous. The numeric data that we have can be discrete or continuous. The easiest way to remember, discrete is countable, continuous is measurable. For example, I am tossing the coin 20 times. How many times did you, let's say 10 times heads, 10 times tails I got. If I toss a coin 20 times, I can get heads 0 number of times, 1 time, 2 times, 3. I can get only those specific values. I cannot get 2.5 heads. I cannot get 3.75 heads. I will only get 0, 1, 2, some discrete values, only specific values. That's what is discrete. Continuous, all values are possible. In my data set, all values may not be there, but all values are possible. The heights of people here. Now, you may say, I am only 5 feet, or 5 feet 1 inch, 5 feet 2 inches, 5 feet 3 inches, 5 feet 4 inches. You may say that this is discrete. Now, that is not really discrete. You are rounding it off. Those of you who are saying 5 feet 3 inches, you may be 5 feet 2.7859 inches. It's my measuring scale that's changing, but value is possible. Every value, every 0.00001 inch is a possibility. Height can be measured in that much. So, all values are possible. That's a continuous data. Okay? So, that is and the easier way. Measurable is continuous, countable is discrete. Let's see if we have understood that. Some questions for you. time between customer arrivals at a retail outlet, is that discrete or is it continuous? Continuous. Why? Time. Yeah, seconds, milliseconds. I can measure in any time. Customer arrival, customer can come. The time between two customers coming 5 minutes, or it can be 4 minutes 85. 4 minutes 85 seconds, so 5 minutes 15 seconds. 4.85 minutes. Okay, anything is possible. Okay. All possible. So it's continuous and it's measurable. Sampling 100 voters in an exit poll and determining how many voted for the winning candidate. Discrete. Okay. Discrete. Because I cannot have, I can have only 50 people, 51 people, 52 people, but not 53.75 people voting for the winning candidate. And by the way, don't take that point by decimal as the difference between the discrete and continuous. Discrete is only takes fixed values. Now, if the fixed values are 1, 1.5, 2, 2.5, 3, 3.5, then it's still discrete. Okay, so don't go by that. Whether all small things are possible or not. How does it matter? You give me the answer. Coin is tossed 100 times. What are you? What is the business problem? What are you counting? Infinite times I am tossing. What are you looking for? Either heads or tails. Nothing else. You cannot. So, what is the problem that you are asking for? Number of heads or number of tails? That's the discrete. Okay, so you are counting. Even in infinite times, I will have 10 zillion, 595 million, billion, billion, whatever, 255 heads. That's it. I will never be able to get that 0.75. Lengths of newly designed automobiles. Continuous. It's a measurable thing. See, I may have a very tight specification range. This car should be 5 feet or 6 feet long, and each component has some specification. So, but within that range, between 5 feet 9 inches, 5 feet 11 inches, and 6 foot 1 inch, every value might be possible. One car might be there, one car might be there. Every value in the range will be possible. So, the range may be small, but every value within the range is possible. That's continuous. Number of customers arriving at a retail outlet during a 5-minute period. Discrete. Now, number of customers. The moment I say number, it is discrete from now on. Okay. 5-minute interval is fixed. 1, 2, 3, 1. Number of defects in the. Yeah, whatever you. I don't need. Number isn't number. Discrete. Okay, fine, discrete. Okay. So I think we are at 1 level. So this is the right time. This is where I start with the mean median mode. I guess I'll start tomorrow. So we have covered the terminology of statistics. What we have achieved today, nothing much, but got you oriented to the program. Normally I summarize everything. I ask people to summarize. There is nothing much to summarize today, but orientation of overall program structure. And then we had a high level overview of data science. What are the types of skills as a data scientist you should possess? What are the types of problems, prediction, optimization, classification, big data management are there? In each of those, what types of applications? Prediction applications, classification applications. We saw some applications from various domains. That's where data science is applicable all over the place. And then we started with some statistical terminology. Before that, we said some motivation. If you think statistics is theoretical, it's all around you. And we saw how it is used to mislead also. Data collection, data understanding, data analysis, data presentation. At every step, people try to mislead. So lies, damn lies, and statistics. Okay. And then from there, we said, okay, so once we saw examples of how people are using to mislead, we saw its applicability in various places, in election coverages, in healthcare, in weather forecasting, in what else? Pharmaceuticals, variety of places we saw that application everywhere. And then finally, we said, okay, statistics is all over the place. Sports, we saw sports as well. Statistics all around us, so we better learn it. Okay, and for that, we started understanding some terminology. Population, sample, census, survey, parameter, statistics. So census, survey, and all those things are right. Parameter is with respect to population. Statistic is with respect to the sample. Okay, and the Greek alphabet is all population. Mu, sigma, they are all population parameters. X bar, S, whatever. Even linear regression, the slope is given as beta. B, if I write B, it is for the sample. Beta is for the overall population. So that's the way it is. And then we said, very importantly, there are variables and data. Variables could be dependent and independent, that's fine. We just need to understand what are we trying to find out is dependent, what we have is all independent. Then within variables, we have that is data. Dependent, independent variables. Yeah, okay. And within the data, we had the numeric and categorical. Categorical two types: nominal and ordinal. Some people actually, when they say categorical, they just mean nominal. They call ordinal as a separate thing. But technically, both are categorical. But that's fine. So ordinal has order, nominal has no order. Okay. And numeric is what? We saw some examples from numeric. Numeric, again, we started looking at the other variables was the discrete and the continuous. Discrete is counting, continuous, all values in a range can be available, are possible. That is what is continuous. And so discrete, continuous, nominal, ordinal, numeric, categorical. Those are your primary things that will haunt you forever from now on. You will always be hearing about that. That is very important. Okay. Parameter statistic, good to know, but many of the statisticians themselves don't care. How does it matter? I think we covered it. That's what it is. So, hope you are excited about the journey to be started from tomorrow essentially. And believe me, you will have fun. And we will have fun. At your cost. Okay. Good, thank you very much. I think the lunch should be ready and we will start understanding data, descriptive statistics from tomorrow, and next week we will speed up. Okay. But I'll simplify it. It will be a pleasure. Thank you very much. If there are any questions, please ask. Else, lunch.
Keep hearing about structured data versus unstructured data. Can you explain more about what is this unstructured data?
All your text, your voice, your audio, what I saw in a nice tabular matrix form, that is structured. A very nice structure to that thing. My blog, Twitter, everything very unstructured. So that's text. Text to voice, audio, video, all that is unstructured.
You talked about data gathering being a major part in statistics. So would we be learning about data gathering from Twitter and all these other platforms through APIs?
Collecting, yeah, that collecting the APIs, etc., that you will do anyway. But most of the part that I deal with, you don't have to worry about it. The organization already have data. What I was trying to show there is where people make mistakes or people try to mislead at what steps. Data gathering was one of the steps. If you have collected incorrect data, how do you fix problems with the data, etc. Sometimes it is unintentional. I'm not saying everything is intentional. Unintentional issues, etc. But issues arise in statistical outcomes that they show at various steps. Was the data unclean to start with? So that's what I referred to. But data gathering, the APIs for the text mining module, I think you will certainly do that. That's not. But the rest we will, yes.
You said that we have one data model for one dependent variable. Okay. So
One data model. Okay, I didn't say that, but yeah, that's here the question also.
let's say we have one solution for one data model, one dependent variable.
One dependent variable is there, yes.
Yeah, so there can be cases where that dependent variable has independent variable which is again a dependent variable for some other cases. So do we?
Yeah, so
we must be having this kind of
no,
component.
so it's not a property of the variable itself that it is dependent or independent. It's the business problem that decides which variable you want to use as a dependent and which one is independent.
Okay.
So if you are solving a problem, whether I should give a loan or not, which was the last column, then that becomes independent. What is it depending on? It's depending on age, gender, income, and all those other variables which are independent. Now, you have a different problem you want to say where you want to see what is the age of the people based on the other variables. So now we won't solve those kinds of problems, no business value to that thing. But if I can twist the question around, then age becomes a dependent. And how am I predicting the age of a person based on their whether they have a loan or not, whether they have how much money they have in the bank account or not, all those things, and I'm predicting, or better than that, maybe probably this thing. How much money will they have in their bank account if I want to predict? I can use the other ones as the independent variables. In fact, whether they have accepted a loan or not can also become an independent variable in that thing. So it depends on the problem you have defined. What do you want to find out? That is dependent. Based on what are independent? In some of the variables you may not need. Like if I have a variable called ID, it just goes 1, 2, 3, 4, 5, 6. I should never ever have that in any of my models. If you just throw this data to the software, it will take that also as a one variable. You will have to consciously remove that. No software will automatically remove an ID. But you know ID has no meaning. So you will have to think of those things, which variables need to be kept, which variables are impacting your dependent variable. What are you trying to find out is dependent, based on what is the independent. It is not based on whether age will be a dependent or not. Age has no such property as dependent or independent. The problem statement tells you what you want to find out. That is dependent. The rest is all independent.
We have seen a lot of examples where stats have gone wrong. That could be either intentional or due to improper sampling.
Here today?
Yeah.
Okay.
So will we be seeing what are the techniques to do right sampling?
Stats have gone wrong. In what sense?
The numbers are incorrect.